Hello everyone. I'm going to take a few minutes and go over solving exponential equations. So an exponential equation is just an equation that has the variable that you're trying to solve for in the exponent. So we'll look at some examples of those. So anything that has the variable you're trying to solve for in the exponent within an equation is an exponential equation. So if you have something like 10 to the x power equals 100. That would be an example of an exponential equation. We all know that 10 squared is 100, so if x is 2, then 10 to the second power equals 100. We're going to eventually get to the point where we'll have like 10 to the x power equals 23. So we know 10 to the first is equal to 10, and 10 to the second power is equal to 100. So to get 23 has to be 10 to some number between 1 and 2 to get 23. But that's what we're moving towards. What we're going to be looking at today is exponential equations, where the bases, that's a lower number, are the same or can be made the same. So if we look at something like 2 to the x power equals 8, that's one we can do in our heads for the most part. We know 2 to the second power, or 2 to the first is going to be 2. 2 to the second power is 4. And we keep going. 2 to the third power is 8. So if we know that 2 to the x equals 8, and we know 8 is 2 to the third power, then x has to be equal to 3. The key here is that the bases on both sides are the same. And there's a property with exponents, or a property with, I guess exponents you could say, where if you have two expressions that are equal and the bases are the same, so if we have, let's say, b to the x equals b to the y, so the bases are the same, expressions are equal, then your exponents, x and y, have to be the same. That's a whole basis for what we're going to be looking at. And one thing that's going to help as we're doing this is this powers to know thing. If you know your different powers, knowing that 8 is 2 cubed, knowing that 81 is 3 to the fourth, things like that will help with this. So next example, we have 2 to the x plus 1 power equals 4 to the x. So what you need to recognize for this is that the bases 2 and 4 are both powers of 2. So on the left-hand side, there's nothing that we need to do because the base is already 2. On the right-hand side, we're going to simply rewrite 4 as 2 squared. That's the only thing that changes. We know 4 is 2 squared, so we're going to write it as 2 squared. Much like you can get 5 ones for a 5 or 2 5s for a 10 when you're making change with money. Here we're just going to rewrite 4 as 2 squared. So it's not changing the value, it's making it look a little bit different. Then we know with exponents, with our properties of exponents, if we have a power raised to a power, then we multiply those exponents. So on the right, we have 2 raised to the 2x power. Now the bases are both the same. They're both 2's. Therefore, the exponents have to be equal. And once we get to there, it's just some algebra 1. So subtract x from both sides, we get x is equal to 1. So let's look at a couple more examples and then go from there. So again, you want to rewrite the equation to get the bases to be the same. That's a key. Once the bases are equal, then the exponents are equal. So that's the goal here. So when you're looking at 121 and 11, the bases for those, both of those are powers of 11. We know 11 to the first power is 11, so we can keep that as 11 to the 5x. On the left-hand side, we know 121 is 11 squared. So we're simply going to replace 121 with 11 squared. We're going to rewrite 121 as 11 squared. And then we use our properties of exponents. So this 2 and a 2x minus 6 have to get multiplied. Make sure that 2 gets distributed inside. So our new exponent is 4x minus 12. And now that the bases are both the same, they're both 11, then the exponents have to be equal. So we have 4x minus 12 equals 5x. Subtract 4x from both sides. We get negative 12 is equal to x. And that's all it is, getting the bases to be the same. Once the bases are the same, then the exponents have to be the same. For number 3, we have 32 and 1/4. That doesn't look like anything we would maybe see, but I'm looking at a 32 and a 4. Go to powers to know. Look at 32 and 4. Both of those are powers of 2. So I'm going to go and rewrite the 32 and a 1/4 both as powers of 2. So we just saw 32 is 2 to the 5th power. So I'm simply going to replace 32 with 2 to the 5th. And we have 1 over 4. Let me do this real quick. Let me write it as 4 5x minus, or 7 minus 5 minus 7x. Whoops. I'm going to rewrite that as that 4 as 2 squared raised to the 5 minus 7x. So on the left-hand side, I have 2 multiply my powers to the 20x power equals 1 over 2 to the 10 minus 14x, because that 2 has to be distributed. So they're close, but I have a 1 over 2 on the right-hand side as opposed to a 2. So remember, with your properties of exponents, we can always change something to a fraction or get rid of a fraction using negative exponents. We're used to taking a negative exponent and putting it in the denominator, but we can actually bring something out of the numerator and make it a negative exponent when we bring it out. Write that. And then we have 2 to the 20x on the left-hand side and 2 raised to the negative 10 plus 14x on the right-hand side. Bases are the same, therefore the exponents have to be the same. 20x equals negative 10 plus 14x. Subtract 14x from both sides. We get 6x equals negative 10. Divide both sides by 6. And x is negative 10/6, which reduces to negative 5/3. That one may have been a little bit easier. There's a couple different ways to do these. If we had taken that 1 over 4 to the 5 minus 7x and made that 4 to the negative first right away, then to the 5 minus 7x. That might have been a little bit easier looking at it that way. You have 4 to the negative 5 plus 7x. And then you can rewrite 4 as 2 squared, negative 5 plus 7x. And you'd have 2 to negative 10 plus 14x. Again, that's on the left-hand side. And that just jumps in right to there. So again, if this seems easier, just rewriting the 4 as a negative 1 right away, that's perfectly fine. If you want to change it to powers of 2 and then change it to negative, that's fine. So it's really up to you there in terms of what you'd like to do. All right, last example then. This uses irrational exponents that we've been looking at, the fractional exponents. Here we want to find what x is equal to. So x equals what? And the key there is it's x to the first power equals what? So just like we solve radical equations, if you had the square root of x equals 7, you would square both sides. Because squaring undoes a square root. Same idea here. We're going to raise both sides to a power so that we have x to the first. So in this example, we're allowed to square both sides of the equation. Here we're going to raise both sides to the 3/2 power. You might be asking, why 3/2? The reason we use 3/2 is that 2/3 and 3/2 are reciprocals. So when I multiply reciprocals, I end up getting just 1, which is, again, that exponent that I'm looking for. So we raise both sides to the reciprocal of 2/3. So we have x to the 2/3 power, that raised to the 3/2 power, equals 9 to the 3/2 power. And we know that x to the 2/3 times x to the 3/2 is going to be x to the first. And here, then it's just a matter of simplifying 9 to the 3/2, which we know we can rewrite that as a square root of 9 to the 3rd power. And the square root of 9 is 3 to the 3rd power, gives us 27. And that's it. Again, the key there is just to get your bases to be the same. Let's look at a couple quick examples, and then we'll wrap it up from there. So if we go to exponential equations practice, let's look at something like number, we'll look at number 1. So 3 to the x equals 27. I know 27 is 3 cubed. Bases are the same, exponents have to be the same. So x has to equal 3. For number 2, 5 to the x equals 625. My powers to know, I know 625 is, if we do 5 to the 4th power. And if you don't have these, you can certainly use a calculator to find them. So 625 is 5 to the 4th, then x has to be equal to 4. If we jump down to number 7, 1/3 and 3, both are powers of 3. 1/3 is 3 to the negative first. That raised to x minus 3 equals 3 to the x minus 1. Power to power, multiply your exponents. Don't forget to distribute. And once the bases are the same, the exponents have to be the same. So if I add x to both sides and add 1 to both sides, I end up with 2x equals 4, so x is equal to 2. And we'll look at number 12 yet. So 125 and 25, both powers of 5. So 125 is 5 to the 3rd power. So I'm simply going to replace that with 5 cubed. 25, I'm going to keep right now, but 1/25 is 25 to the negative first. So I'm going to get rid of that fraction first. And then power to power, I'd multiply my exponents. So don't forget to distribute negative 3x plus 6. And now I'm going to do that replacement where I know 25 is 5 squared. So I'm simply going to replace 25 with 5 squared. And then power to power, multiply the exponents. So have 3x plus 9. Again, don't forget to distribute. And 5 to the negative 6x plus 12 on the right. Bases are the same, so exponents have to be the same. So if I add 6x to both sides, that gives me 9x. Subtract 9 from both sides, gives you negative 7. And then divide both sides by 9 to get x equals negative 7/9. And that's it. All right, hope you guys have a good one. Again, let me know if you have any questions.